everyone, welcome back to my channel, and in this video we are going to start the series for the BCS401. The subject name is Analysis and Design of Algorithm. In this video I am going to cover module 1. So I have divided this module into two parts. So this video is going to cover the part 1. If I get more interaction for this video, I'll try to cover the part 2 and followed by all other modules. So if you like this video, you just comment on the comment section for module 2, module 3 and module 4 as well as module 5. And another thing I want to mention here is that many students get confused like from where to start, what to rate for the exam, right? So there is no time left to think about it, right? So this video is for those students. They can just refer this video, and whatever short notes which I am going to provide, by the end of the video I'll tell you where you are going to find the short notes. So stay till the end, because here I am going to tell you easy tricks to remember the points, because teachers are going to look for the keywords in your answer. So if you remember that specific keyword, it is going to be easy for them to correct the papers, and also it's easy for them to give you the marks. And that's it. So without wasting any time, let's get started. So this PPT is going to cover topic wise. So first topic is algorithm basics and design process. Then I will show you the year, in which year the question was, how it was asked. Okay, and after that we will read the PYQs question, and then I will explain you the answer in simple exam writing points. In part 1 of this video, we will cover these 5 topics. So topic 1 is algorithm basics and design process. Topic 2 is analysis framework, and topic 3 is asymptotic notation, which is very important and the fundamental core of the subject. And topic 4 is big O addition theorem, and topic 5 is order comparison and dominant term. Is that clear? So why I have mentioned the topics over here? Because if you remember, I know that everyone can't remember the exact sentence how it was asked for the exam, but it's definitely possible to remember the keywords which can be used in the question, because there will be many questions repeated, but what they will do is they will just reframe those question or rephrase those question, right? So that is the reason I'm just mentioning here the topics. Okay, so one by one topics we will discuss, and along with how it was asked in the question paper. So let's get started. So here you can see topic 1 as algorithm basics plus design process they have asked in a question. Okay, so how they have asked, you can check. It is asked in June, July 24. What is algorithm? Explain the fundamental of algorithmic problem solving. So this was asked for 10 marks, right? So in the coming slide, I will tell you what answer is for this specific question. Okay, I'll just read out the question. And next question, which was asked in December 2024-2025, they have asked, explain the various steps in algorithm design and analysis process with the flow diagram, which is asked for 8 marks. Next, you can see June, July 25, with a neat diagram, explain different steps in designing and analyzing algorithm. So this was also an 8-mark question, right? So students, from this slide itself, we understand that the algorithm design process is a repeated question in previous year question papers, right? So in the another slide, one more question we have, which is asked in December 2025-2026. The same concept was asked. So how they have asked, see, define algorithm with the help of flowchart, explain the various stages of algorithm design and analysis process. So here you can see it was asked for 10 marks. So don't worry, I will explain you what is the answers for this question. Okay, so I will explain the answer for algorithm basic and design process. Okay, based on this concept only those questions are there. Okay, and do not worry, also I'm going to give you the notes, okay, where you're going to find the notes at the end of the video. I'm going to tell you. Okay, so that is just a minimum pages, I guess only 20 pages or to 25 pages notes it is, which I have covered according to the syllabus. If you read that much, that is more than enough to score good marks in your exam. Is that clear? Let's start. So here you can see what is an algorithm. So now let us understand what is algorithm. An algorithm is a finite sequence of clear, unambiguous and effective steps used to solve computational problem and produce the required output. Now remember the characteristics of algorithm using the shortcut keywords or shortcut letters, right? So what I have used here, IOD FE. So if you remember IODFE, so these are the characteristics. So what does I stand for? It means input. So input means what an algorithm can take zero number or n number of inputs. Okay, so then algorithm is going to take zero or more number of inputs. Is that clear? What O means? It means output. An algorithm must produce at least one output. Okay, so the word itself, if you remember, which is input, so what is input? It takes zero or n number of inputs inside an algorithm, right? What is output? Any algorithm or any program is going to produce at least one output, right? What D means? It is definiteness. Every step must be clear and unambiguous, right? So what F stands for? It is finiteness. An algorithm must stop after a finite number of steps, right? And next we have is E, which means the effectiveness. Every step must be simple and executed, right? So here I repeat, E means effectiveness, and what it is going to do, what it means, it is in every step it is going to make it simple and executable, right? It's very simple, right? Within 2 minutes you are prepared with this answer, which is characteristics, right? And also the algorithm, definition of algorithm. So this much if you remember and write in exam, you are going to get 8 or 10 marks. They can ask for 8 marks or 10 marks, right? So remember this word, which is IODFE. Clear? So next question we have is fundamental of problem solving. Now let us see the fundamentals of algorithmic problem solving. Okay, this was asked in previous year question paper. So these are the stages we follow while solving the computational problem. First step or the first stage is understand the problem. So what it means, before writing in any algorithm, we must know what is the question, right? We need to understand the question, we need to understand the problem statement, then only we can write the algorithm, right? So then only we can write the step or the solution for that specific problem, right? So what first stage it is, understand the problem, explain. Okay, next second stage, what you have to do is identify the input and output. Input means what data will be given to the program, and what output means what result we need or what the output it is going to give that to that specific program. So that you have to write. So second stage we have is identify input and output. Third, we have choose the algorithm design technique. For example, we have so many algorithms, right? Brute force, divide and conquer, greedy method, dynamic programming, and so on. So we have to choose the algorithm design technique. Fourth stage we have is design the algorithm, right? So here we write the step by step logic or step by step process what we are going to do. And next fifth step we have is prove correctness. Here we are going to check whether the algorithm gives correct output for all the valid inputs or not. And sixth step which we have is analyze the time and space efficiency. So this tells you how fast the algorithm is and how much memory it is going to use, right? And the seventh stage we have is implement and test. So here we are going to convert the algorithm into a program and then we have to test it. And eighth step we have is refine or improve the solution. If the algorithm is very slow or not efficient, definitely we have to improve it, right? So if the program or whatever program we are going to run or execute, if it is not efficient or if it is consuming a lot of space, so definitely we can just improve the program, right? We can refine it. So that is nothing but eighth stage. What we have is refine or improve the solution. Okay, if algorithm is not efficient or if it is working slow, we have to improve it. So memory trick I have given here, understand. Then next stage we have input output, then technique, design, prove, analyze, code, and then last stage is improve it. So moving to the next slide, we have a design and analysis flow. So this block diagram you have to remember. According to this block diagram, you have to explain. Same thing as it is. Okay, just now I explain you the stages, right? So for that stages, you have to show the design and analysis flow. So write down this flow chart, or you can say a block diagram, and also the explanation for the each stages. So first what we have, first we have understanding the problem in the first step. Okay, where we are going to then what we are going to do, we are going to understand the problem and then we are going to identify the input output. After that, choose the technique, then we choose the suitable technique and then design the algorithm. And then what we do, once the algorithm is designed, we can prove its correctness, right? And then analyze its efficiency. Efficiency includes the time complexity and space complexity. This is very important in analyzing the efficiency. What it includes in efficiency, it is going to include space complexity and the time complexity. After analysis, what you have to do, code and test the algorithm, and finally refine the solution if it is required. So this is the flow diagram which you have to remember. Next topic we have, which is analysis framework. If anywhere in the question, if you see this keyword, the okay, so these kind of possible questions you are going to get, and of course we will discuss the solution for this. So first question what you have, it is explain the various steps in algorithm design and analysis process with the flow diagram, which was asked on December 2024, 2025, January 2025. Next, we have June, July 2025. With the neat diagram, explain different steps in design and analyzing the algorithm. Next question you can see, which was asked in December 25, January 2026. The question was define algorithm with flowchart and explain the stages of algorithm design and analysis process. So the analysis framework is usually asked along with the design process. For exam, we must know the input size, basic operation, time efficiency, space efficiency, and the cases like best case, worst case, and average case. Okay, so definitely we are going to see. So this is the analysis framework. So first, analysis framework means what? It is the method used to analyze the algorithm efficiency. Understood what is analysis framework? It is being used, or it is the approach or the method to use to analyze the algorithm efficiency. First important point is we have the input size, which is represented by n. And input size means what? The size of given data. For example, let's say if we have an array of 100 elements, then n equals to, it is going to be 100. Second point, or the second framework here, you can see it is a basic operation. So basic operation is an operation that is going to execute most frequently. For example, in searching of any element, comparisons of basic operation. So here you can see, here I have taken an key value and I'm trying to check the array element with which is equal to the key value or not. Okay, so operations means it can be addition, subtraction, comparison operators. Okay, so here we are checking the value where the a of I element value is equal to the key value or not. So, okay, so any example you can do, take and explain. And the third point is the time efficiency, where it is going to tell like how it is running, okay, along with the time and along with the input size. So here it is very important, whenever the input size increases, okay, at that time what it is going to, even the time is going to increase. Okay, if the input size is increasing, the execution time, okay, the process of execution time is also going to increases. Okay, so it tells you how running time increases when the input size increases. And the fourth point here you have is space efficiency. It is going to tell you how much extra memory is being used by the algorithm. So in the exam format, how you have to write the input size and then identify the basic operation, count how many times the operation has been executed, okay, and how much time it is taking. When the input size increases, obviously time is also going to increase. This is very important. And then finally state the complexity. Okay, space efficiency of text. Next, moving on to the next slide. So here we have best, worst and average case. So now let us understand what is best case, worst case and average case. So best case means the minimum number of operations required for the most favorable input. For example, in searching of any element, if the key is found at the first position itself in an array, that is the best case, right? And the worst case, what you can see is it is going to take the maximum number of operations for required for the least favorable input. Okay, so that is the worst case. For example, let's say in searching element in an array, if the key is absent or not found only, or let's say it is going to be in the last position of the array, so that is the worst case. It is going to take time to search that element, right? Where it is not been found in any of the starting element, it is found in the last element, right? So that is the worst case. And then we have average case, which means that expected number of operations for typical or random input. For example, let's say I want to search an element in an array and the key may be found somewhere around the middle of an array. Okay, so that is nothing but your average case. So very important point, best case, worst case and average case are the input situations where we call it as big O, omega and theta are the mathematical bounds. So do not mix them blindly. We will understand that in the next slides. So next, very important, the fundamental and the core topic of this subject is asymptotic notations. So very important and 100% question will be asked on this topic. So this is one of the most important topic in the module 1. So in June, July 24, the question was asked like this: explain asymptotic notation with example. This was asked for 10 marks. And then here in December 2024-25, the question was asked like this: give formal and informal definition of asymptotic notation, which was asked for 6. Okay, so you must prepare with big O, omega and theta, okay, both formally and informal. So again here you can see in June, July 2025, the question was asked like this: define algorithm and explain the asymptotic notation big O, big omega and big theta notations. So are you understanding? These are all repeated questions. They have just rephrased those questions in every question paper. So that is the reason I am mentioning the topic name. If that word asymptotic notation is mentioned anywhere in the question, what answer should you have to write is what I'm trying to say. Alright, so list and explain asymptotic notation used to compare the order of growth with an example, which was asked in December 2025 and January 2026 or January 2026. So clearly asymptotic notation is very repeated question topic. So for exam, writing meaning, formal definition, The use cases and example for each notations is very important. So that means write big O, big omega and big theta separately you have to write. Okay. So moving on to the next slide where we are going to have the explanation for asymptotic notation. So here you can see which is going to tell you what asymptotic notation it is trying to tell. It is trying to tell us how an algorithm is growing when the input size becomes very large. It's very simple definition. Are you understanding what asymptotic notation is trying to tell us? How an algorithm grows when the input size becomes larger or very large. So it does not focus on small input size, it focuses on large input size. Okay, what I'm trying to say, it does not focus on small input size, but it definitely focus on large input size. Are you able to understand? Very simple thing, that is the definition. So first try to understand what asymptotic notation is trying to tell us. It is trying to tell us how an algorithm is going to grow when an input size, which is n, becomes very large. And next 2 points, it does not focus on the small input values. It is going to focus on large input size. Definition is clear. It is now in your mind, right? Very easy definition. And next, why do we use it? First, it is going to ignore the machine speed. And second, it is going to ignore the programming language. And third, it is going to ignore the constants. And fourth, here you can see it ignores the lower order terms. And fifth, it is going to help to compare the algorithms independent on the hardware. For example, here you can see we have fn raised to 2 plus cn plus 10 we are going to. So here you can see you need to understand. So here the dominant term is n square and order of growth it is theta of n square. Clear? So dominant term is, so what I said, it is not going to focus on smaller values. It is going to focus on larger values. So here, which is the larger value? 10 is the larger value? N is the larger value? Or n square is the dominant term? Right? So 5, 3 and 10, those are constant values. So we have to ignore it. So that is what points I have written here. Okay. So next, and then what is the dominant term over here? It is n square. So order of growth equals to theta of n square. Clear? Very easy. So simple rule is you just ignore the constant and smaller terms. Keep only the fastest growing term. Okay, so here the dominant term is going to be the n square. So order of growth is nothing but theta of n square. Clear? So next we have big O of notation. Okay, so in the previous slide you just hear what I'm trying to say. I'm trying to tell you the definition and the example for asymptotic notation. So these points you can remember and write in exam. Nothing difficult, right? So please note down this point, write down the example for asymptotic notation. Next we have a big O of notation. So now let us understand big O of notation is nothing but it is going to give you the upper bound. It is very important. Upper bound it is going to give. And in simple meaning you can say it is at most. Big O means at most. So you can remember big O as a roof, okay, or at most, and also it gives the upper bound. Next formal idea you have to understand. So here you can see f of n is less than equal to c dot g of n. Right? And for all n, what it is trying to tell? N is greater than equals to n naught. Okay, so this is the formal idea, the basic concept for the big O notation. Right? So this means what? F of n will not grow more than g of n. Are you trying to understand what it, this formal idea, what it, a formal definition, what it is giving? It is telling us that f of n will not grow more than g of n after the certain value of n. Clear? So big O, when the exam, okay, when in exam if it is asked big O, so prove big O, which is the upper bound at most or worst case upper limit, you can say. Okay, and then you can give example for it. Clear till here? So now let's start with next. So yeah, in this slide here you can see there is an example. Here you can see 3n plus f equals to big O of n. Why big O of n? Can anyone tell me? Because I have taken 3n plus 5. So 5 and 3 are the constant value. So you have to ignore the constant. So here n is going to be a larger, okay, or the dominant term you can say. So why? Because n is dominant term, because n value can, here it is not given specifically like what is the n value. It can, n value can be changed, right? So it can be 5, it can be 100, it can be 200. So the n value has been larger, right? It has been increasing at any point of situation, it can increase the value of n. So that is the dominant term. So what I have written, big O of n. Okay, so this example you can just write down in your exam. So let's move to the next question, which is next notation, which is big omega notation. It is going to give you the lower bound. The simple meaning for omega is at least. You can remember omega as a floor. For big O, what I said, you can remember it as a roof. Omega is nothing but your floor, right? Or you can just remember it as an at least. So your formal idea you have to understand, it is f of n greater than equals to c dot g of n. So use omega when in exam it asks like prove omega or the lower bound at least or minimum growth. When they are saying, you have to write this formal idea, formal definition of the big omega. Okay, so here again you can see what you are supposed to do. You have to write the example as well. So here you can see same example, it is 3n plus 5 equals to, what I said, you have to ignore the constants. So here 3 and 5 is constant value. So I am ignoring it and I am giving priority to the n. Okay, so omega of n. So this example you can write for the big omega notation. So remember these points when it is going to be used, like prove omega, and when we are talking about lower bound and at least and the minimal growth. Okay, so these keywords you have to remember for the big omega notation, and this is the formal definition. Okay, conceptual definitions for the big omega notation, and along with the example you can just write it, and once you are done with this, write down in the sentence. Okay, next we have is big theta notation. So here what we are having, so we have to understand big theta notation is going to give you the tight bound. The simple meaning is theta means exact growth. Exact growth, what exact growth it is going to be, it is going to be told by the theta notation. So here is the formal idea. Here you can see c1 of, okay, c1 g1 g of n is less than equals to f of n, which is less than equal to c2 of g of n for all n greater than equals to n naught. Okay, so when in question, wherever tight bound, order of growth, time complexity, efficiency class, okay, so these keywords you have to use for the big theta notation. Okay, so whenever they are asking you to write the exact growth for a specific program or for the specific algorithm, at that time you have to make use of big theta notation. Clear? So along with the example, you can just explain. So here again same example, it is 3n plus 5. So I told you, you have to ignore the constant value. So n can be constant over here. I mean the n value can be exact growth. So it is nothing but the theta of n, because it is going to grows exactly like n. Clear? So next, which notation to use? Okay, when this you can just remember, this is the most important slide for the students. If the question says upper bound or at most, you have to use the big O, and if the question says lower bound or at least, you have to use the omega. Clear? And if the question says the tight bound or the order of growth, you can just use the theta. So theta means what? It is the exact growth. And if the question sees that time complexity or efficiency class, use theta as a preferred final answer. So this you can take the screenshot or just note down it somewhere. If these keywords are used, which notation you have to use in your exam. So many students get confused like when to use big O, big omega and theta, right? So this slide is going to help you to understand at what point of situation you have to use the notations. Clear? Next, we can move to the next slide, which is basic efficiency classes. So this slide shows the order of common efficiency classes. This slide is also very important, like which is given the higher preference. So here you can see, if we move from left to right, complexity becomes the worst. So 1 is less than log n is less than n is less than n log n, and then we have n log n less than n square is less than n cube, and then n cube is less than 2 raised to n, and 2 raised to n is less than n factorial. So as we move from left to right, the complexity is going to become the worst, or you can say the worst case. So example, you can see here fn plus 2, which is theta of n, right? So next what you can see, because the dominant term is n, 5 and 2 you have to ignore because that is the dominant term, right? Next example, here you can see 4n square plus 7n plus 9, right? So what I am doing here, 9 is constant, I am ignoring. 7 is the constant, I am ignoring, right? 4 is constant, I am ignoring. N square, so you just check this thing, right? If I check from this, n square is there, right? So n square is the dominant term. Here of course we have n, so n is where? N is here, right? N log n less, and here we are talking about worst case, so theta of n square. Okay, here in this example I am talking about worst case, that is the reason I am taking n square, theta of n square. Clear? Next, what I am going to take the example, it is 2n plus n cube. So what is the answer? And here I am talking about n worst case. So if I am talking about worst case, definitely what I have to use? I have to make use of theta of 2 raised to n. Okay, so here you can see 2n is the worst case as compared to the n cube. So n cube has the n cube is less than 2 raised to. So here these are the given terms which is there in the question. T1 of n is going to be belong to big O of g1 of n. It is given in the question. You just check it. See here, t1 of n belongs to big O of g1 of n, and t2 of n belongs to big O of g2 of n. So the same thing what I'm trying to do is I'm just writing it as, okay, what it means is t1 of n be, less than equals to c1 of g1 of n. Similarly, t2 also I'm writing t2 of n less than equal to c2 of g2 of n. Okay, so whatever is given, that I have just converted. Okay, what it means is less than equal to c1 of g1n and less than equal to c2 of g2 of n. Clear? So what is the meaning of this? T1 is controlled by G1 and T2 is controlled by G2. Clear? So next we have to understand the max. What is max and how we define? So G of n, okay, how we define the max? Okay, so this is standard. G of n equals to max of G1 of n comma G2 of n. This is standard format. Okay, so whenever we are talking about big O, no, max term we are going to take. Okay, so G1 of n comma G2 of n. So what it means, so let's say I'm having G1 of n as n square and G2 of n I am having n cube. So which is the bigger term? N square is the bigger term or n cube is the bigger term? It is n cube, right? So we are going to select any one of the bigger term from this. Okay, that is nothing but max of among these two, which one is the bigger term, that is going to be the G of here. So here what I'm going to do is I'm going to write G1 of n is less than equals to G1 of n and G2 of n is less than equals to G of n. Okay, why? Because whichever is going to be the bigger term, same value we are going to write for G1 and G2. Is that clear? Next, let's understand how we are going to prove it now. Okay, so this was the given thing. Now we are going to prove it. So here you can see T1 of n is less than C1 of G1 of n plus C2 of G2 of. So what I have done, same thing. Okay, T1 of n plus T2 of n I have written less than equals to C1 of G1 of n plus C2 of G2 of n. Okay, so I have combined this T1 and T2. Clear? So now, since we know that, what we know here, we know that G1 of n is less than equals to Gn and G2 of n is less than equals to G of n. Right? So what I am going to do, I am going to substitute it as G of n for G2 and G1. So here you can see C1 of G1 of n plus C2 of G1 of n, G of n. Because here in the given terms we have already simplified. Okay, what we have done is we are trying to give G1 equals to Gn value, and similarly for G2 of n I am trying to give the G of n value. Clear? So whichever dominant term it is going to be, that we are going to give the value to the G of n. Okay, so once we have substituted or replaced, what I am going to do, I am going to take G of n as a common and C1 plus C2 is going to be inside the brackets. So this becomes the constant, right? So next, here you can see, therefore T1 of n plus T2 of n as it is belongs to big O of max of G1 of n comma G2 of n. Okay, so this is constant, right? I am going to ignore this constant, and here what G of n? It is nothing but O, right? And what I am doing, G of n is nothing but here I have written, right, it is max of G1 of n comma G2 of n. Clear? Here I am talking about big O, right? So O of, and here I am having Gn, right? So what is Gn? Here in the given we already found out what is Gn. It is max of G1n comma G2. So this is how we are going to prove the given things, okay, to the big O of max G1 of n comma G2 of n. Clear? Is that clear? Next we will just move to the next question. Here we have order of comparison and dominant. Okay, so they have given compare the order of 1 by 2 n, n minus 1 and n2. Very easy question this is. So what are the steps? See, here you have to compare this term and this term. So which term is the dominant term is what you have to find out. So here let's simplify 1 by 2 n of n minus 1. So how you are going to simplify? 1 by 2 n is nothing but n minus 1, right? So how I can simplify? First I will just multiply n into n is n square minus n into 1 is minus n. Okay, first step we have just simplified or expanded it, and then what I am going to have? I am going to simplify these things, right? So 1 into n square, which is n square by 2 minus what I am going to have? Minus n by 2. Okay, I have just separated these terms, okay, by simplifying 1 by 2 into n square minus n. Okay, so 1 into n square is n square, 2 is there, so that it will be as it is. Next, what I have to do? 1 minus n is minus n, and this denominator is common, which is 2. Okay, solve in your notebook, you will easily understand it, what I am trying to say here. And next, once you get, okay, so now it is simplified completely, okay, it is expanded. So now you can see we have n square by 2 minus n by 2, and also they have told to compare with what? N square. So let's say if I had here, in this example we are getting, for this thing I am getting n square, and whatever is there in the question, it also it is telling us to compare with n square. So highest term is n square itself, not n, right? So n square is having the order of growth. Okay, so that is the highest power term or the dominant term. So what is the final answer? Therefore both have the same order of growth. Okay, so they had told us to compare with n square, and for this when we expanded or simplified, here also we got n square. So let's say if we had solved some other problem they had given, and if say I have got as n cube, so n cube is greater or n square is greater? Obviously n cube. So at that time what you have to tell is the given expression which I simplified has the highest order of growth, which is n cube as compared to the n square. Okay, so that n cube will be the dominant term. So in this case here we have n square, so n square is going to be the dominant. So that's it for this video. And also I wanted to mention you that if you need notes for this particular module, you can just go to the VTU smartprep.com. Okay, so in the first slide I have showed you, so just let me so just go to this website vtusmartprep.com, and here you will be finding the notes study material for this particular subject. Okay, and also once you visit the website you have to sign up. Okay, so enter your details, write your name, enter the email address, create a password, and next you will get the confirmation mail. So confirm it in your email, and then you have to sign into the website, which is vtusmartprep.com. So there you're going to find the short notes for this particular subject, and I hope you liked the video and you understood whatever I explained just now. So if I get more interaction for this video, definitely I'll continue the series, and you can just comment on the comment section below this video so that I will try to continue those series for module 2, module 3, module 4 and module 5. So that's it for this video. See you in the next video. Till then, please study